If you have ever used AndyNoCode or ChatGPT for automation, you know how powerful AI can be, but you also know how fast the API calls can add up. Remember when Stable Diffusion came out? Before that, AI art was locked behind paid tools. Then suddenly, anyone could run it for free on their own computer. The same shift is happening now with OpenAI GPT OSS. For the first time, you can run GPT-4-Level AI on your own machine. No API fees, no surprise bills, and your data stays private because nothing leaves your computer. For founders, small business owners, and marketers, this is not just another tool or model, it's a game changer. And in this video, I'll not only explain why, I'll also show you the real automation you can build with GPT OSS step by step. Most AI tools today have the same problems. They feel like a black box. You don't really know what's happening inside. They're expensive with API calls that grow fast. And they send your data to the cloud, so you don't have full control. This is why OpenAI GPT OSS is such a big deal. Here are the main benefits. First, no API fees. You can run the model on your own computer for free. No extra charges, no surprise bills. Second, full data privacy. Your prompts, documents, and customer info stay with you. Nothing leaves your system. Third, open and customizable. You get full access to the model. You can adjust it, fine-tune it, and make it work the way you need. Fourth, it works offline. Because it runs locally, it still works even without internet, and that makes it more reliable. Fifth, strong performance. The big 120 billion model is close to GPT-4, great for reasoning and summaries. The smaller 20 billion model is fast for chat, and with up to 120,000 tokens, it can handle really long documents. And last but not least, easy automation. You can connect GPT OSS directly into tools like AndyNoCode, so your workflows are cheaper, private, and fully under your control. With GPT OSS, you are not just using AI, you are owning it. Your costs stay low, your data is safe, and your automations belong to you. First, we'll teach you how to install 4 essential packages. The first package is Ollama. It's used for running AI agents on your local machine. The second package is the Python package for dockling. It helps us recognize PDF documents. The third package is N8N. N8N is our workflow automation tool. The fourth package is ngrok. It allows you to make your local machine publicly accessible. Now, the first package is Ollama. We mainly search for Ollama on Google. Once you enter, you'll see it supports Mac OS, Windows, and Linux. Just click download and select the suitable program to install. After you've installed Ollama, you can open the program. You'll see an interface similar to a GPT chat room. In this interface, you'll have an option to choose the model you need. This time we'll use 2 models. The first one is GPT OSS 20B. Of course, if your computer's GPU is relatively powerful, you can choose the 120B model, but this time we'll use the 20B model for testing. Since this was the first time you're using Ollama and you haven't downloaded this model yet, you need to send out a message. So the program can download the model first. You will see it reply to you with a message. Next, we need to install another model. We are going to use a model called Gemma 34B. Of course, if your computer has a stronger GPU, you can also try more advanced models. It will also send a message out to start downloading the model. After downloading, you'll see it immediately sends you a message. If you're using Linux, you just need to type the command Ollama here. You'll then see a help program. For instance, if I need to use a particular model, I just use the command Ollama run. For example, Gemma 34B, you'll see it uses a similar chat interface, allowing you to run the model. Let me explain why we need to use 2 models. Firstly, if we use GPT OSS, its reasoning abilities are stronger. This allows for daily reasoning exchanges. The second one is Gemma, which actually has vision capability. This means it can analyze images. So in our test, we can give some images to Gemma to ask what this picture is. Once we have it installed, our second task is to install something called Dockling. Since our model cannot read PDFs, we need to use a Python project called Dockling. You can see this on GitHub. You can find the setup guide inside it. It also includes many different tools. The installation process is very simple for us. It's called pip install dockling. First, open your shell. The first step is to check the script you're using. For example, you might be using Python or Python 3. You need to know exactly where their paths lead to, or check if pip is globally installed. If not, you'll need to install it directly in your Python. We can open a script. For example, python 3-m pip install. The package name is Dockling. After installing, Dockling will be automatically added to your system. Where is Dockling located? If pip is globally installed, you can usually use a command called Dockling. If your pip is not globally installed, you may not be able to find the Dockling command. Therefore, you'll need to find the absolute path. It's usually installed in a user folder, like username/library/python 3.9. The final step is to install ngrok. Because we need to connect our N8N to Telegram, we need to make our local computer accessible to the outside world. We can search for ngrok. First, log in to the ngrok website. Once you're logged in, you'll see it supports different operating systems. Choose the OS that suits you. Then select Install. After you have installed it, you need to enter this command. It will link your account to ngrok. Once it's installed, you're good to go. Next, our step is to install N8N. We use the simplest method, which is using npx n8n. We just need to enter this command to start N8N directly. Before opening N8N, we need to run one more command. First, we need to start ngrok. We need to connect it to port 5678. So we input ngrok http 5678. You will see it generates a URL. We need to copy this URL. This is our public link to port 5678 on our computer. Then, before using the npx n8n command, we need to enter an environment variable. It should be webhook URL, which equals the domain you got from ngrok earlier. Then type npx n8n. If it's your first time running it, it will install initially. Once everything is ready, you'll see it's now available on your public domain. You can press O to open your N8N software. The first time you open it, there will be an ngrok prompt. We activate yes. Afterwards, you can log in to N8N. The agent workflow is divided into 4 main parts. The first part is the inspection panel connecting to Telegram. The second part involves examining PDFs using the Dockling tool to understand their content. The third part is for screen inspection, where we'll use Gemma to analyze photo content. Finally, there's a general document inspection. Let's start with the first part on Telegram. To connect with Telegram, we need to use the Telegram trigger node. All nodes can be found in the panel on the right. Back in Telegram, you'll see a trigger node. We'll use a node called onMessageCall. When we open onMessageCall, the first step is to set up your Telegram account. You can create new credentials here. The access token can actually be found within a Telegram bot called BotFather. Go to BotFather and enter new bot to create a new one. Follow its instructions to set up your own Telegram bot. This is Andy's local tutorial bot. Remember, the bot name should always end with bot. Once we have set up the bot, you'll get an access token. Place this access token in the specified spot to activate it. Then we'll press save. You'll see that it has successfully connected. After setting up the bot, we can proceed to test it. Alright, then you can access your bot. You can start your testing now. How do you perform the test? It's next to this trigger. There will be a button called Execute Workflow. You click on Execute Workflow. You can send a message in. See what responses you get. First, I've disconnected all the links. For example, let's send a message saying hi now. You'll see that it receives the hi message. You can roughly see its contents. For example, it comes from here. What's the chat ID? What's the text? So our next button will connect to something called a switcher. This switcher can distinguish what type of message has come in. For example, if it contains an object called document, it will identify it as a document object. If it's a photo, it will have a photo array. It will treat it as a photo. If it only has text, it will treat it as text. A point to note here is we choose exists here. We have to select exists based on its type. For example, now I'm going to send a document for everyone to see. Let's execute the workflow again. Then I'll send a document to this bot. After sending, you'll see it's identified as the document workflow. How do we decide it's a document? When you see on the left under Input Trigger, there's an additional field called Document. This box actually represents an object, so we need to carefully choose whether it's an object or an array. Then select its exists, the condition. For example, this is an object, exists condition, so it identifies it as a document. Similarly, the photo is the same. Let's try again. Suppose this time I send a photo over. You'll see this time it decided it's a photo object array. How to set it up? Same as before, but be careful this time. You'll see it has 3 lines of this icon. So this time we need to select the exists within the array. It can determine it's a photo. Of course, the text is the same. It belongs to text. Once we've sorted this structure, we can proceed with the 3 types of identification functions. Firstly, the simplest, let's start with text. Within text, our Telegram will directly connect to our AI agent. First, we can pull an AI agent from this node. Once it's down, we need to set it up. But since our previous input is Telegram, we have to use define below node to pull the text object back. So you'll see that there's a text input. We can directly pull it back here and you'll see it's set up. At first glance, you should see these 2 nodes are blank. The first one needs to connect a chat model, because the chat model we're using this time is the Ollama chat model we installed earlier. We can directly search for the Ollama chat model. The second step is to set up an account. Initially, creating new credentials is straightforward. Just hit Create New Credential. Usually, we won't have an API key because we're not connecting to a remote Ollama. Just press Save and it's ready. After setting up, you can choose your model. Earlier, we installed 2 models. One is GPT-OSS, the other is Gemma. This time we have a GPT-OSS model. After putting it in, the second step we need to do is add memory, because to ensure our chat remembers the results. So we can use a memory node called Simple Memory. Our memory also uses a connector node now, but this time we use define below. We need to set a Telegram ID into it because each chat for every user is independent. There's an independent chat ID here. We can put this chat ID in, and after that, this context window length, you can set it longer. Depends on your GPU. See how much it can remember of our chat inside. Alright, once we've configured the AI inside, our next step is to send a reply back text message. This node can also be found on the side. It's a Telegram node. It's for sending a message out, so under message action, it's a send text message function. After putting it in, we need to fill in 2 things. The first is your chat ID. As mentioned, each user with Telegram has a unique chat ID, so put it in this node. The second is what our reply message text is. We can find that from the upper AI agent, place the text in the reply location. Then we're ready. Alright, once everything is set up, we can immediately test our agent. First step, press Execute Workflow. Alright, then we can send a message. You'll see it automatically executes the AI agent. It will also automatically send out a message. Then you'll see it receives a message. This message is from our local Ollama response. Our next step is to try sending a photo into the bot. The process for sending a photo is roughly the same. Previously, we've set up a switch. It will receive some photo files. Next, we'll need a Get File node. Similarly, you can find it in the side panel here. Within the Telegram category, find a Get File node. Inside this node, we need to set a file ID. We can place the photo into Telegram. And then, once Telegram receives the file in this node, we just need to input the file ID. Where can you find the file ID? It's in the message section beside us. Inside, there's an object called photo. The photo object shows it has photo 0, photo 1, photo 2, photo 3. These represent different photo sizes. because Telegram automatically compresses your photos. When we hand it over to AI for analysis, we will use the clearest photo. So we can't directly pull photo 3 in here. Why not? Because sometimes these photos might not be of high resolution. It might be unable to identify the third number of the photo. We need to use dynamic to find this photo. We should place the json.message.photo part here, replacing this number with length-1. This retrieves the total length here, showing how many objects are in the photo. For instance, it has objects 1, 2, 3, 4, 4 in total. Here, it would equal 4. But 4, since arrays start counting from 0, we need to subtract 1 here. That will fetch the third object. You can also look here and see that json.message.photo.length-1 will automatically show 3, which is the maximum number, fetching the last array object. By placing it in, it will automatically get the object. Finally, we select file_ID and will retrieve the file ID of the largest photo. Then, when we execute step, you'll see it will fetch the photo data. Next, we can pass it to the next node, which is our LM node. When we click inside, we can see our task needs us to set it as describe the image and answer the user questions. First, we connect LM node to this node because our input binary is named data. So we choose message type as image binary here, then select the name data and that's it. Image data can be set to auto, allowing it to automatically choose the photo clarity it needs to recognize. Then we finally drag our question back to the caption question. You can find it inside the Telegram trigger. At the bottom, there's a caption. This is the question. We place it back here and that's it. After that, we still need to connect the model since GPT-4-OSS can't recognize photos. This time, we'll use the Gemma 4B model to analyze the photo. Of course, it can also use more advanced models for even clearer understanding. Once this is set, we can visualize the photo. After it runs, you'll see it generates a result. For the next photo, we use a send text message node again. Place the answer in the text field. Checking the ID is the same. Use the chat ID from the Telegram trigger. Then we can reply with this message to our Telegram. Here, you can clearly see it says the answer is the image shows a lion. There will also be a detailed description responding according to our caption. Through Gemma's AI, the local AI will answer the question. Finally, we have the document description. First, we connect the document switcher. Link it to the first process we discussed before. Let's place a PDF into Telegram for testing. Alright, after we output it, you will see it runs through the first process. The first step is to create a temporary folder. This temporary folder will store the PDF and output analyses we'll use later. First, we'll use the TMP folder inside root path. Delete the previous folder files first, then create a new folder here. Next, we use the node get file from Telegram. The structure is the same. Insert the file ID. We can then download the file from Telegram. Here is our PDF from earlier. After that, we'll move this file into the folder we just created, the temporary folder. Of course, you can use any path you prefer. Use the original file name. This file name is usually obtained using $JSON to access the object. But since it's a binary file, we'll use a different syntax, the binary syntax, to access this object. Inside, use the file name from binary data. We can retrieve our input file name. After completing this step, our next command will be to call the Docling Python library. Depending on where you installed it, execute according to the installed path to run the Python library. We'll then take the Docling file, then we'll place the PDF file back in the second row. In the third row, we'll select an image export mode. Use the reference mode. We won't extract all images from the PDF to text, reducing the file size. Finally, we set an output mode back into our temporary folder. For more usage methods, visit Docling's official document. You'll see examples there, different methods for parsing PDFs. They provide advanced OCR models or varied output formats. Once everything is set up, we'll execute this step. If the output is successful, we proceed to the next node to read the generated file. We expected the PDF output to be in the temporary document output folder. Our output format is MD. If no other format is set, it defaults to MD format. So after reading the MD format output documents, we'll know the PDF content. Let's execute this step. We'll extract the file 1.md data file. Inside is Markdown containing the entire PDF content. Next, we'll convert this MD binary file back into a text file. Since our input is data, export requires a text file. Choose Extract from Text File node. Then execute this step. You'll see it converts a binary back to a text format, passing it to the next node. Finally, we use the AI agent node we used before. The prompt is simple as well. We'll pass the PDF file text to it. We will also include our user's question from earlier in Telegram. Using the caption, we'll input it. It translates the entire file and question to our local AI agent for processing. This time, our chat model uses the GPT-OSS:20B model. Its reasoning ability is stronger. We'll add a simple memory so it can recall prior questions. We can execute this agent now. After it runs, return its result to the final node, send a text message to the user. The first chat ID comes from our initial Telegram trigger. Our text output directly uses this agent's output. Execute the final node. In the end, it provides short answers. It includes a flight confirmation receipt stating the airline. There are also document details. Here you can fine-tune your prompt to ensure it answers questions the way you want the AI agent to respond. So that's it for today. We've covered installing Ollama, Darkling, ngrok, and Nate to build a local AI agent with Telegram. Hope you guys enjoyed this tutorial. Let me know what you think in the comments below, and I'll see you in the next video.